Okay, I mentioned interfaces. What are they? Well, the high-level idea is that interfaces are models for classes. Most of the time, interfaces are like abstract classes, but that don't have any concrete methods and don't have any mutable, that is, modifiable, instance variables. However, Java 8 changed the rules a little bit, and in Java 8, interfaces can have concrete methods, which are sometimes called default methods. They can also have static methods. But most of the time, both in Java 7 and in earlier Java versions, interfaces contain only abstract methods, and they act as a model for a class definition. So here's a quick example. I have an interface called interface 1 and an interface called interface 2. Each of these interfaces gives specifications for methods, but no implementation. There are no curly braces and actual bodies. Also, notice that I didn't say the word public in front of these methods. That's because in interfaces, unlike classes, the methods are automatically public. There'd be no point in having a private method in an interface, so they're public by default, so you don't need to say so. And so I've said, oh, anything that claims to use interface 1 must give a definition of method 1, and anything that claims to use or to be an interface 2 must give a definition of method 2. And the way that you claim to use or to be an interface is to say implements. And then you give the interface, and if you want to, you can give more than one interface. And so you can list as many interfaces as you want, separated by commas, which is different than extending. You can only say extends for a single class. You can have a parent class, a grandparent class, a great-grandparent class, a great-great-great-great-great-great-grandparent class, but you can't have a mother and a father when you use extends. You can have only one direct parent class, whereas the interfaces, you can implement as many as you want. And basically, when you say implements, assuming that the interface only has abstract methods, you're basically promising the compiler that you'll have certain methods. And so interface 1 mentions method 1, interface 2 mentions method 2, and so if you implement the interfaces, you must give real definitions of those methods, concrete definitions with curly braces and actual method bodies. So Java knows ahead of time that your class, if it claims to implement interface 1 and interface 2, will have method 1 and method 2. All right, why is this so useful? Well, as with abstract classes, using interfaces enforces behavior. It guarantees that the classes that implement the interface will have certain methods, will have their own specific definition of those methods. But they're more flexible. With interfaces, you can implement several of them, whereas the abstract classes, you can only extend one. In Java 8, interfaces can also have static methods and concrete methods. More on this in a few slides. But in all Java versions, including Java 8, interfaces cannot have instance variables that are modifiable. They can't have mutable or non-final instance variables. Let's talk a little more about the idea that in Java 8, interfaces can now have real methods. And when I say real methods, I mean actual method definitions, not just method specifications. Now, interfaces still cannot have mutable, modifiable instance variables, but they can have real method definitions, and you label them with the keyword default to do that. So here's an example. So most of the time, the purpose of an interface is to give a method specification that will then be implemented in the class that claims to implement the interface. But if you label a method as default, then it can actually be a real concrete normal method. Now this is a little bit odd. Why does Java let you do this in interfaces? That's not what interfaces are. Well, the long and the short of it is it was kind of a kludgy hack. In order to support lambdas and streams, which we'll talk about later, Java had to have a way of retrofitting existing code. And the only way to retrofit existing code without breaking things was to add concrete methods to interfaces. So I think if Java had done this from the very beginning, maybe they would have just had regular multiple inheritance, but they didn't. But nevertheless, this is still quite useful. So in all Java versions, the main differences between abstract classes and interfaces is that with interfaces, you can implement any number that you want, whereas abstract classes, you can extend only one. But starting in Java 8, interfaces can have concrete methods and static methods, just like abstract classes can. So the conclusion, the point of all this, is that starting in Java 8, there's not much of a reason to ever need abstract classes unless you need modifiable instance variables, mutable instance variables. You might as well use interfaces for everything because they can do what abstract classes can do, and they can do more because you can implement more than one. Okay, let's use interfaces to give the final and best attempt at the problem of summing up the areas of an array of mixed shapes. So in the last version, we used an abstract class. Here we'll use an interface. We'll make an interface called shape. And as before, inside that we'll give the specification, not the definition, not the implementation, of a getArea method. We'll have all of the actual real classes implement this interface. And because we implement the interface, we'll be required to give a specific definition of getArea. And as before, we'll make a shape array containing circles, squares, and rectangles, and so forth. As before, we'll pass the array to the SumAreas static method. And as before, in SumAreas, we will define the incoming parameter as a shape array, loop down, and add up the results. But we can now do something different. We can move that method to the interface itself. So shape.SumAreas will be the place to put it rather than shapeUtils. That makes sense. We already have a shape interface. Why not put the static method there as well rather than the user having to remember two different class names? All right, so let's see this in action. We'll make an interface called shape, and it will have a method specification. Notice the semicolon, no curly braces, but it'll also have a static method, SumAreas. This was not legal in earlier Java versions, but it is as of Java 8. That's a very useful idea. And then instead of saying that circle and rectangle extend shape, as we did with an abstract class, we'll say that they implement shape. The compiler will then force us to give a specific definition of getArea. And then, just as before, we'll use a shape array, but everything in the array will be a more specific type. We'll pass it to our static method as before, but our static method will now be in the shape interface. So, using interfaces was just as easy as using abstract classes, but it's more flexible because sometime in the future, if you want to implement another interface or you want to add a concrete method to the interface, you can.